Welcome back to Nature of Code in Rust and GGEZ. We're moving on to example 2.1 forces. In this case, the example is going to be just creating a force out of thin air, not really modeling one out of the real world. The idea is we're going to have a gravity force and a wind force that is always blowing to the right. We can see the example running here from P5.js, where we have a ball that has a constant gravity being applied to it and a constant wind being applied to it. It then bounces off the right-hand wall and it bounces off the floor and just sort of repeats this movement back and forth. Let's go and write this in our code. So the main thing that we're going to want to do is stop having all of this Perlin noise. We just don't need this anymore. We don't need a down force either. We're just going to need two forces, gravity and wind. So we can have a wind force, that's going to be a vector 2, and a gravity force is also going to be a vector 2. Let's go ahead and create those. For our wind force, let's go ahead and make this 0.1, moving to the right and not moving up or down at all. And for our gravity, we're going to have this not be moving left or right, and let's just have this be a 1.0 constant down for us. And we'll go ahead and store this away. Then down here, we don't need to create a wind force anymore. We're going to apply a wind force. That's going to be a self.wind force. And then we're also going to apply our gravity. So gravity force. And we don't need to do this entire x off, y off. Okay, so this is good so far. This will get us a force that's moving to the right and down. But we have some changes we need to make to our mover. Now we have our mass, and in our last exercise, the mass is being set by that. That's fine. We're going to keep that. But what we need to do is make sure, well, the force being updated should work out. I think that the only thing we need to care about here is this check edges. So I'm going to go ahead and get our screen size here. And then I'm just going to reset what our check edges means. So let's do the right-hand side first. If our location.x, if you're, well, plus our self.radius, if you're greater than the screen width, not that, screen width, then we're going to reset location x equals the screen width minus self.radius. And we want to reverse our x velocity. All right, that should handle that. Let's also do the floor. If that is greater than, and now we need screen height. Reset the y location. What is sure? This is going to be screen height minus self.radius. And then we want to also reverse the y velocity. All right, let's go ahead. Well, we've got 3 errors. What are you on them? Cannot find location. So, these definitely need to be self here. We have them on most of them, just not these 3. No more errors, just some warnings. Let's go ahead and run this and see how it works. We start in the center. Maybe we can make it more interesting by starting on the left-hand side. I don't think it matters too much. We have that right wind force that is blowing the ball to the right consistently. And we also have this gravity force. So basically we have a perpetual motion machine here where the ball is just constantly moving to the right. It can never really get anywhere and it never stops because once these, these forces are constant. They're never like canceling each other out. They just exist. And this is example 2.1 forces. Let's go ahead and clean up some of these warnings and then we'll close the video down. Okay, so we're not going to use noise. We don't need this sure. Oh, apparently that's from algebra. And that's it. So with that, that is example 2.1 forces. I'll see you in the next video. Have a great day and bye.